everybody. This is our second video for the home lessons we're doing. I hope everyone is healthy and safe. I know it's a lot to get used to being home this much, but as Wednesday comes around and next week we'll be doing some things at home together. So for Math 6 we've been focusing on geometry. So today what we're going to be doing is, the first lesson we did area of parallelograms, and so today what we're going to do is we're going to focus on area of triangles. Okay. Now if you see up here at the top of the screen we have the formulas that we're going to do, which is area is 1/2 base times height, or the decimal version of 1/2, so area equals 5/10 times base times height. So the reason why this formula works, now if you remember from the video that we watched on parallelograms, the parallelogram formula was just base times height. Now the reason why the triangle formula is 1/2 base times height is real simple to see. So if you take this rectangle here, and like we said, the area formula for a parallelogram is base times height, and a rectangle is a parallelogram. One thing that you can do is if you took a line diagonally and you went from one corner to another, you'd actually see that if you cut this parallelogram in half, you would actually create a triangle. So if you did base times height, but then you cut that total in half, you'd have half the area, which would be just this triangle on the bottom here. So for instance, let's say I told you that the base was 10 centimeters, okay, and the height was 8 centimeters, okay. You would know that 10 times 8 would give you the area of 80 centimeters squared, or square centimeters. But considering the fact that we are only looking for the area of the triangle, we would only need half of that. So that would mean that each of these triangles would represent half of the 80. So each of these triangles would be 40 of the square centimeters. So that's essentially how the formula for the triangle works. It's half of a parallelogram formula because a triangle is half of a parallelogram. The other things that we can kind of talk about just as reminders, the base and the height always meet at a right angle. So just like when we talked about parallelograms, the base and height have to be lines that meet at a right angle. So if you look at this triangle right here, I know we have these two sides that meet this other third side, but neither of these are a right angle. So typically what you're going to see is, you're going to see, just like we saw with the parallelogram, you'll see kind of a dotted line or a dashed line in the middle where you'll see the right angle and you'll see the height here, and then the base would be the side of the triangle that meets that height. Now one other thing I want to say about the height is, the height's always going to be to the top point in the triangle. So the height's always going to the highest point and to the base at a right angle, okay? And one other thing, and you'll see it with some of the triangles that we're about to do, that base doesn't always mean the side that's on the bottom. So the base will have to meet the height at a right angle. So the base, I almost want you to imagine if we took this triangle here, we kind of rotated it maybe 90 degrees or 180 degrees, that the base may be up here, and that's okay. So base doesn't necessarily mean the side that's on the bottom, it means what meets the height at a right angle. So now what we're going to do is we're going to go over a few examples of these. So we have some simple ones here. Here we have a right triangle, so we see the right angle right here. And so the base and the height always meet at that right angle. So in this case, we're going to do 1/2 times the base, which is 4, times the height, which is 3. Actually, I should say we do want to start with the formula. So 1/2 base times height. Alright, so now when I multiply all three of these together, 1/2 times 4, which is 2, and then 2 times 3 gives me an area of 6 centimeters squared. Okay? And again, if you wanted to imagine this whole rectangle, you would just do 4 times 3, which would be 12. So this piece would be 6 and this piece would be 6, and that's where that 12 would come from. But since we're only looking for the area of this triangle, we only want 1/2 the base and the height, which would be 6. Okay, so here's our next example. Okay, now this picture, this would be an example where the height is actually outside of the triangle itself, kind of like some of the parallelograms we did in the first lesson. But then the other thing that you see here is they kind of do a straight line, okay, to kind of meet where the height would be. So this is where our right angle is, but I want everyone to notice something here. That when we're doing the area of the triangle, we only want to use the actual base of the triangle. So in this case, we're only using the 5 because this 3 right here, this 3 that's the imaginary line, is imaginary. So we're not going to include that as part of the base of the actual triangle. They're just showing you the distance until where it meets that right angle for the height. So the height is 4, and then we have a base of 5. Again, we only want the base of the actual triangle. So this imaginary line is just showing us where it would meet the height. And again, the height is coming from the highest point of the triangle. So we're going to start with the formula. So area is 1/2 the base times the height. So I'm going to do 1/2 times 5 times 4. Now, one quick reminder here, like I know sometimes when we're multiplying something by a half and it would be a decimal, you can multiply these numbers in any order you want to, just using the commutative property. So for instance, since all you're doing is multiplying 3 numbers, it doesn't matter the order in which you multiply them. So for instance, you could do 5 times 4 first, which is 20, and then 1/2 of 20 is 10, or you could do 1/2 times 4, which is 2, and then 2 times 5 is 10. But either way, you're going to end up with an answer of 10 centimeters squared. Okay? And again, the other thing you could also do here, if you're more comfortable with this, is instead of doing the fraction 1/2, you could do the decimal 0.5 times 5 whole times 4, okay, which would give you that same value of 10. Okay, and again, the base and the height meet at a right angle. This just happens to be an imaginary line that's on the outside of the triangle. Typically, you'll see that in what we call an obtuse triangle because there's an obtuse angle in this triangle. All right, so the next one here, this is one where we have the height actually inside the triangle because you see both of these sides right here aren't going to be the height because neither of them meet the base at a right angle. So wherever you see a right angle, you know that's where your base and your height are meeting. So again, I'm going to start with the formula. This time I'm just going to use the decimal. So 0.5 times 45 times 26. So you guys who are working at home, you can use a calculator for this. Okay, because again, we're not really concerned about the computation part of this. We're more worried about you guys just actually doing the area. All right, and you should end up with 585 feet squared. Okay. Again, here's your height right here. I'll even highlight it so we can see. Here's, and then it meets our base at a right angle. Okay. Okay, there's actually one other one I want to show you here. So this is an example where I said don't be too thrown off that the base is always on the bottom. So for instance, here we see that where we have a base and a height happens to be right here. So when I write my formula down, area is 1/2 the base and the height. I want to focus on where I see the right angle because the base and the height meet at a right angle. So if you look here, we have 14, and what meets 14 at a right angle? This line on the inside, which is 12.1. Okay? So we're going to multiply 1/2. Let me get that pen back. We're going to multiply 1/2 times 14 times 12.1. And for our area, we have 84.7 meters squared, or square meters. Okay? Okay, so now what I want you guys to do is I'm going to give you a couple examples to try on your own. So what I'm going to ask you to do is, here's the picture here, okay? This is a right triangle, so it should be fairly easy to see the base and the height. So again, I want you to start with your formula, 1/2 base times height. And again, I'm fine if you want to use the decimal version here. So I want you to pause this and give it a shot, and then come up with your answer. All right, hit pause and give it a try. All right, so you should have done 1/2 times 24, okay, times 7, all right? So 1/2 times 24 is 12. 12 times 7 is 84 inches squared. Okay, all right. Here's our second example. Just a reminder, we don't want to use 3 because 3 is just that distance to that imaginary line. So when we're getting the actual area of just the triangle, we want the actual base of the triangle. So what I want you guys to do is I want you to hit pause, and I want you to come up with the area for this triangle. Go ahead. All right, so what you should have been multiplying here is 1/2 times 10 times 6. Okay, 6 is the height. It meets the base at a right angle. So 1/2 times 10 is 5. 5 times 6 would give you 30 feet squared. Okay. I also apologize, my marker's looking a little bit shaky. I'm not sure why. All right, so we have one more example. All right, do this last one here. Again, you want to use the formula. Area equals 1/2 base times height. All right, go ahead and give it a shot. Hit pause here and do it on your own. All right. All right, so for the formula here, we're going to fill it in, which is area is 1/2 times 20 times 14. Again, we want to focus on where the base meets the height. All right, so it has to be at a right angle. So 1/2 times 20 is 10. 10 times 14 is 140 feet squared. All right, everybody, this is our second lesson in our home unit. So we will see another quiz on Canvas and an assignment to do that matches up with this video. So good luck, everybody, and continue to stay safe. You'll expect to see more videos coming up in the next few weeks, and hopefully we'll see you guys soon. All right, stay safe. See ya.